Lesson 11.1 takes us into what I would call our data analysis chapter. We need to talk about permutations, combinations, fundamental counting principle before we move into probability, which is what we'll be doing the next couple of days, if I recall correctly. Now, first topic is fundamental counting principle. And I would like to think it's one you would have been introduced to in middle school at some point. Maybe you don't know it by name, but fundamental counting principle. If event M can occur M ways and is followed by event N that can occur N ways, then event M followed by event N can occur M times N ways. Okay, the short of it. You've got 3 pairs of pants laying on your bed, 2 pairs of shirts. They're all interchangeable. How many outfits could you create? And that's, you pick a pair of pants and you have how many pants choices? 3. You pick a shirt, you have how many shirt choices? 2. 3 times 2 is 6. You have 6 possible outfits. That's what fundamental counting principle does, is it helps us figure out how many possible outcomes a situation could have. Are we okay with that idea? Maybe, maybe not. Okay. Well, let's look at example 1. We're going to get a little fancy right off the bat here, but a license plate in Maryland in 2004 included 3 letters followed by 3 digits. If repetitions are allowed, how many license plates are possible? Okay. So, this is why I said you're going to want calculators out by your side today, because you don't want to have to do this math. First of all, how long, that's not the right way to ask the question. I'm trying to come up with a better way, but how long is this Maryland license plate? How many different pieces are on it? 6, yes? There's going to be 6 spaces on a Maryland license plate. So, 1, 2, 3, 4, 5, 6. It includes 3 letters. So, when if I'm trying to pick this license plate, not that we get to pick it, but how many choices do I have to go in the first spot? 26, because there are 26 letters in the alphabet, correct? Does that make sense? Because this is letters. Now, what about the next spot? It is also a letter. How many options for the next spot? Okay. Repetitions are allowed. So could you repeat the same letter? So we still have 26 options. Does that make sense? If you picked A, if A got picked the first time, it could be picked the second time in this case because repetitions are allowed. If repetitions were not allowed, we'd have to go down to the 25, some of you said. What about the next case? 26, because there are 3 letters. Now, and realize, what are we going to be doing with all these numbers? We're going to be multiplying them eventually. Okay, now, think carefully, especially if you're working ahead of me. What about the next place?
10, 0.
Okay, so first of all, it's followed by 3 digits. The next one is a digit, which you guys are catching on to. What do we mean by digits? Single numbers, right? We need to all hear this now because this will come up. So, what digit would be the starting digit? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Did you watch my fingers there? The point I'm trying to make is how many digits are possible here? There are 10 digits possible because when you look at 0 through 9, that is 10 digits. Be aware of that, right? That's a trick to learn right now because that's an easy one to mess up. Okay, what about the next spot? Another digit. Repetitions are still allowed, so we still have 10 choices. And the final spot?
10.
Still 10. How do you get your answer? 26 times 26 times 26 times 10 times 10 times 10. This is why I said we need calculators today, right? Nothing fancy on the calculator right now, but you don't want to do this math by hand. I don't want to do this math by hand. And I'm more willing to do some math by hand than you guys usually. So, what are you guys getting?
17,576,000.
Yep. It was 17,576,000, or 17576,000. And that is how many license plates are allowed. That's a lot of license plates. On the flip side, there's a lot of vehicles that need plated, right? Most families have at least one vehicle. Most families have more than one vehicle. Every vehicle needs their license plate, right? Okay. Let's try the next one then. In 1912, the license plate in Maryland included only 4 digits. If repetitions are allowed, how many license plates are possible? Thoughts?
Just 10. All 4.
Okay, so 4 spots, and we're allowed 10 on the first spot because we're back to digits, right? There's 10 digits. Repetitions are allowed, so we can use 10 again, 10 again, and 10 again. Don't try and shortcut your math. What is 10 times 10 times 10 times 10?
20,000.
A 1 followed by 4 zeros, so 10,000. Anyone that goofed up and said 40? Get that used now to get that mistake out of your way, right? 4 tens is 40. Well, not when we're multiplying. Easy enough. You just have to keep your head straight, and it's not bad. Okay. A different state's license plates includes 3 letters followed by 3 digits. If repetitions are not allowed, how many license plates are there? So, how many blanks do I need if I'm setting this up? 6, because again, it is 3, which comes first? 3 letters, 3 digits. So it's still the same idea of 6 blanks. How many options for the first blank? Okay, it's letters. Please realize there are 26 letters in the alphabet. This is why you came to math class, to be reminded of these small little things today. Okay, we put a letter in the first spot. What about the second spot? 25, because repetitions are not allowed this time. And when repetitions are not allowed, we need to decrease our number, right? Because some letter ended up in that first spot. And whatever letter I used can't be used again, so now I only have 25 choices. What about the next spot? 24. Because then we took away another letter. What about my next spot? Okay, now we're talking digits. Remember, digits, there are 10 digits, 0 through 9. So 10 for my next spot. What about the next one?
9.
We used a digit, and we put it in there. We have one less digit to choose from, so 9 and then 8. And that was all because repetitions are not allowed now in this particular example. Grab the calculator, do some typing, get a big number, right? What you get?
11,232,000.
Okay. 11,232,000. So interesting if you compare our first answer versus our second answer. We went from 17 million to 11 million by taking out repetitions. So we lost a lot of options there. Okay. In how many ways can you file 12 folders, one after another, in a drawer? Do you understand what they're asking here? How many blanks am I going to need? 12, because how many folders am I arranging, filing, however they said it? There's 12, right? So we're going to be looking here. There's my 12 blanks. Not that you have to write your blanks out, but that's my teaching method. That's my teaching tool. Okay, I've got these 12 folders. How many choices do I have to put in the first spot in my drawer? I got 12. How many folders for my next spot? 11, because one of those folders got left in that first spot, right? So as I arrange these, one folder's in the first spot. Now I've got one less to pick from, so I'm down to 11. Then what? Now I've got 2 less to pick from, so I'm at 10. Then 9, 8, 7, 6, 5, 4, 3, 2, 1. All the way down to, does it make sense that if you're arranging 12 folders, you're down to 1 for the last slot? That's a lot of calculator punching, isn't it? But what are we getting? $479,001,600. That's an awkward number to say.
That's, wait, so I thought it was just 12 times 12.
Oh.
Me too. So this is
So now think about that, guys. When you're making choices, if you've got 12 items, you're just trying to arrange them in order. You've got 479 million options there.
Oh.
Boggles my mind to think about. Now, as we move into the next part, okay, you want the easy way of doing that on your calculator so you don't have to type in 12, 11, 10, 9, so on and so forth?
Yes.
Okay. This is something called, and it's introduced down below, so when I go to my next page, you'll see it. But this is something called a factorial. When you're multiplying the number, multiplying by every number along the way, all the way down and ending at 1, this is called a factorial. And in math, it is represented as 12 with an exclamation point. I don't read it as 12 exclamation point, though, because I'm not your English teacher. I read it as 12 factorial because I'm your math teacher. Now, a scientific calculator has an exclamation point on it. So I'm going to type 12 into my calculator, and then I'm going to look for my probability button. And even if you have a different calculator than mine, it's there somewhere. Okay? So we just have to figure it out. So I'm going to do 12 factorial, so I'm going to do 12. Mine, you see my PRB button here? PRB stands for probability. If you have a different calculator, look for a probability button.
You got it.
And when I do probability, notice, we're going to talk about permutations and combinations, but if I arrow over, what is that third thing? An exclamation point. No, you did not need a decimal. Sorry. I didn't realize what you're asking. Okay, so 12, exclamation point. Guess what I'm going to get when I hit enter?
The answer.
That 479,1,600.
So can you only do it with like just like the 12 or we count it down?
No, you can do it with any
So
factorial.
how would you do it with like the first?
Okay, well we can't, you have to be counting down to 1. Sorry.
Okay.
Yeah, you can do it with any number as long as you're multiplying all the way down to 1. Okay. Now, those of you that have other calculators, you're going to have to, it's there somewhere. Look for a probability setting, look for an exclamation point. It's there. I can help you find it at some point. Did you find it?
That was under the math one.
Okay, I say the graphing calculator, most everything's under the math menu somewhere, and there's a probability menu in the math menu, isn't there?
Yeah.
I don't use it as much in my graphing calculator, so. Okay, and I can help you guys find them if it's not appearing to you, but I promise it's there. Your calculator most likely has it. Okay, so next part, what we did right there at the end was something called a permutation. And a permutation, we're going to have permutations and combinations today. A permutation is an arrangement of items in a particular order. In other words, when we talk about this arranging a set of items, where order matters, okay? Where if I switch two items in my order, that's two different answers. So the fundamental counting principle is this example. So when we were just arranging those file folders, there's 12 of them, right? Order mattered there. That's why there were so many choices. Now, factorial. I just talked about factorial, right? A factorial is a way to denote numbers many times used in a permutation using an exclamation point. For example, when you see 5 exclamation point in homework, realize that means we're going to do 5 times 4 times 3 times 2 times 1. Now, you can do that by hand on your calculator, or you can use that button if you found the button on your calculator. Number of permutations. So we will talk about, and permutations can still be done setting up the blanks like what we've been doing, but we can also think of it in a different way. Number of permutations of n items of a set arranged r items at a time. And so the idea, this formatting right here, the number of items, n items arranged r items at a time. So you'll notice this is NPR right here. You notice when I was just demonstrating factorial on my calculator, did you see that NPR there? And I said, oh, we're going to use that in a moment. We'll be able to use that and talk about it. But we're also going to talk about how to do it on hand. So this is the idea, not so much like the last one where it was 12 items arranged 12 at a time, but this would be an example of 10 items arranged 4 at a time. So if you've got 10 items and you're trying to pick 4 and arrange them in order, this is what the permutation would look like. You do 10 factorial on top, divided by 10 minus 4, so subtract the two numbers, factorial on bottom. 10 factorial divided by 6 factorial, 5,040. Okay. Example 2 will take us into an example like this. So let's look at this. 10 students are in a race. First, second, and third places will win medals. In how many ways can 10 runners finish first, second, and third, assuming no ties are allowed? So it says it's a permutation. Does it make sense it's a permutation? If runners are finishing first, second, and third, does order matter there? It matters, right? Finishing a race first versus finishing third, is that the same? No. Okay, especially if we're talking about medals. And so this is an example of a permutation. And I'm even going to write up here, order matters. So this is an example of a situation where order matters. How many runners are we picking from here? 10. How many are we trying to arrange at a time? 3. So when we talk permutation, the official notation would be 10 runners arranged 3 at a time. So this is the whole n items arranged r at a time. 10 runners arranged 3 at a time. Now, check out your formula. If it's 10 runners arranged 3 at a time, what does that say to do? On top, we're going to put our big number, right? So on top, we're going to do 10 factorial. On bottom, n minus r factorial. So what am I going to do in this case? (10 minus 3 factorial). Well, 10 factorial is going to stay 10 factorial for a moment. What is 10 minus 3? 7. So this is 7 factorial. Now, you can do this a couple of ways on your calculators. Could you do 10 factorial divided by 7 factorial?
Yeah.
Yeah. I could do 10 exclamation point divided by 7 exclamation point. I got 720. Okay. Could you use your calculator to help you? If I'm going to use my calculator, I'm going to have to type 10, go to PRB, notice it's NPR, so that is 10 items arranged 3 at a time. Same answer there. Okay? Could we do this by hand?
Yeah.
You could. Because think about it, guys. If we go, back to what we were doing with the license plates earlier, we're trying to place how many people? You're trying to place 3 people, yes? How many options for the first spot? 10. Someone wins first. Now how many options for the second spot? 9. Someone wins second. How many options for the third spot? 8. Does it work out the same? And it does. Any way you go about this, you are getting that there are 720 options. Just 10 people in a race, but for those 10 people to finish first, second, and third. 720 options. Blows my mind to think that there's that many options, but. Did you find one way you liked? I know, you guys complained about words. Yes, you have to read and understand the words. However, we've done a lot worse. I mean, come on, guys. I'm trying to be honest here with you. Okay. Have you tried the top of the next page? In how many ways can 15 runners finish first, second, and third? I'm going to get in the habit of asking now, does order matter? Yeah, order matters because you're finishing first, second, and third. Okay.
What about ties?
We're assuming no ties. Okay. So, that means we're doing a permutation. We're picking from how many people? 15, and we're trying to arrange them 3 at a time. Now, do me a favor, don't just jump to your calculator. Can you set this up using the formula? On top is n, so 15 factorial. On bottom is 15 minus 3 factorial. So I'm going to have 15 factorial divided by 12 factorial. Or if you want, first, second, third. 15 people, 14 people, 13 people. What'd you guys get as an answer? Okay. There are 2,730 ways these 15 people could finish first, second, and third. Okay. We talked about fundamental accounting principle, how to find number of outcomes. We talked about permutation, where order does matter. Within that, we talked about factorial, how to use that exclamation point, yes? Now we're going to talk about combination. And a combination is a selection in which order does not matter. No placing, no specific order at all. So that would be like taking the last problem and then changing it to, in how many ways can 15 runners finish in the top 3? In other words, not awarding specifically first, second, third, but just how many ways can there be, 3 runners? 3 runners be the top 3 runners. So, similar setup here. Number of combinations of n items chosen R at a time. Notice it's NCR. So, n items chosen R at a time. It's very similar, isn't it? N factorial on top. On bottom, you still have n minus r factorial, but you also have to multiply by n r factorial. The example here, 5 combination 3. 5 factorial on top, divided by 3 factorial, and then times 5 minus 3 factorial, which ends up being 2 factorial. So you will notice that it's 5 factorial divided by 3 factorial and 2 factorial, which those two numbers are going to add up to be that top number every time. Let's look at our example and we'll practice putting them in the calculator. What is the number of combinations of 13 items taken 4 at a time?
Pardon the interruption. At this time, could all of the AP chemistry students please be released for lunch? Again, at this time, all AP chemistry students please be released for lunch. Thank you.
Okay. So combination of 13 items chosen 4 at a time. So I did 13C4. Yes, you could put that straight in your calculator, but do me a favor, hang out with me for a few and let's talk about some stuff. Okay. What's going to go on top? Okay. N factorial, so 13 factorial. What's going to go on bottom? 4 factorial, because that's r factorial. And then it's n minus r, so 13 minus 4 factorial. Now, if we clean this up, it's 13 factorial over 4 factorial times 9 factorial. Be very careful if you plug this into your calculator at this point. I would put parentheses around your entire denominator. However, can I show you guys something? Do I have time? How quick I have time. I won't do this on a lot today, but I want to show you something real quick. A way to do this by hand, actually. I know it sounds crazy for me to say because we're going to get big answers here. But think about doing this by hand. 13 factorial. What does 13 factorial mean? What does that mean? I ended up writing it. I wasn't going to write that all the way out, but 13 factorial means 13, 12 times 11 times 10 all the way down to 1, yes? Hang with me for a moment. I want to show you something. What's 4 factorial mean? 4, 3, 2, 1. What's 9 factorial mean? 9, 8, 7, 6, 5, 4, 3, 2, 1. Barring I didn't make any silly mistakes and leave any numbers out. I love canceling. I know not all of you do, but do you notice anything here? Are there a lot of numbers in common? How about I start by canceling out 9 through 1? How are you with that? Do you notice some other pieces that we could cancel? What do you know about 4 times 3? That's 12. Could I cancel out the 12 with it? Could 2 divide into something there? 2 can divide into what? 10. So if I divide that 2 and it becomes a 1, 10 divided by 2 is 5. I just went from a whole bunch of crazy numbers to what? 13? times 11 times 5. It's going to give you the answer of 13 combination 4. What answer did we get? What was it? 715? One way or the other that you did this, you got 715? Okay. The next one just says find 8C3. So 8 items combined 3 at a time. Do you have a way you want to do that? C3, if we set up the fraction, it is what? 8 factorial over 3 factorial times 8 minus 3 factorial. So 8 factorial over 3 factorial times 5 factorial. This is one, if I recall, that I could do without a calculator if I needed to. And I will be honest, there is an advantage to me showing this to you. There are times your calculator doesn't do the numbers so big. So just beware there. But if I do this the long way, that I know you guys are saying, really, Mrs. Sargent? But I like it. 8, 7, 6, 5, 4, 3, 2, 1 on top. 3, 2, 1 on bottom. And 5, 4, 3, 2, 1 on bottom. Is there some canceling that can be done? Five cancels with 5, 4 with 4, 3 with 3, 2 with 2, 1 with 1. And what else can cancel? 3 and 2 can cancel with 6. What am I left with? 8 times 7, which is?
Please pardon the interruption. At this time, if the AP students have not been released for lunch, please release them for lunch. Again, at this time, AP chemistry students. Again, at this time, if AP chemistry students have not been released for lunch, please release them for lunch at this time. Thank you.
I just need to see that.
Nope, you're fine. Okay, example 4. Shortcut my time a little bit here, but in these situations, we're going to be asked, is it a permutation or is it a combination? And then what is the answer? So we're going to have to shortcut getting to the answers, but we can at least talk about, basically, does order matter or does order not matter? That's going to define whether it's permutation or combination. Okay, a chemistry teacher divides his class into 8 groups. Each group of students submits one drawing of the molecular structure of water. He will display 4 of the drawings. 8 groups, going to display 4. In how many ways can he select the drawings? So, you need to stop and ask yourself, does order matter and it's a permutation, or order does not matter and it's a combination? What are your thoughts?
Combination.
Why?
Doesn't matter. It just
Okay.
says it just says it's not.
Does it matter which drawing he picks first?
No.
No, it just matters that your drawing gets selected, yes? And so, for that reason, this is a combination. It's not like he's placing them first, second, and third. It's just picking 4 items. That falls into the combination category. Now, if we're going to do a combination, this is a combination of how many items are we picking from? We're picking from 8, and how many are we picking? 4. So this is 8 items combined with 4. Because I'm running out of time, I don't know if you guys got an answer or not, but one way or another, you can do the answer like we did above. Yes?
Do you care if we just start calculators? Or do you want
I don't want you relying on just the calculators. Guys, don't back up yet. I've got 3 minutes here. We've got 2 more answers. I at least want to talk about permutations, combinations. Permutations, combinations. B. In how many ways can the chemistry teacher arrange the drawings on the wall? Does order matter?
Yes.
If we're talking about arranging something, that word right there, it matters, because otherwise you're going to tell me there's one arrangement for all for all 4 drawings. Is there just one arrangement? No. And so for that reason, because it uses the word arrange, this is going to be a permutation. Okay? Now, permutation. How many items are we picking from again? 8. And how many are we arranging? 4. So you could think of this as 8p4. You would get an answer of 1,680. And again, we've done the math of how to find them, right? You've hopefully gotten that figured out. I'm just trying to get what matters here. C, you will draw winners from a total of 25 tickets in a raffle. First ticket wins 100, second wins 50, third wins 10. How many different ways can you draw the 3 winning tickets? Does order matter? Do you care whether you get picked first, second, or third here? Oh yeah. We want $100, not $10, right? So order matters. This is a permutation. What kind of math would we do here? How many are we picking from? 25. And how many are we picking? 3. So 25p3, which is 13,800 ways. Okay, guys, don't just rely on the calculator. There may be times where I expect you to be able to set up the fractions. Okay, so don't just rely on the calculator. Be able to use different methods here. We'll talk more going on farther, but do the homework for tonight. It's lesson 11.1 in Math Excel, and it should be there and available, assuming I didn't goof it up. Have this done for tomorrow, please.